Okay, so here's what we're going to do for today. What we're going to do first is just a quick refresher on what we talked about last time. So last class we talked at some length about the difference between monomials, binomials, trinomials, essentially what polynomials are, and then we did some addition and subtraction operations. So something like 3x squared is a monomial. We have one term, and everything in here is related by multiplication. As soon as we start throwing in addition or subtraction, suddenly now we have polynomials. In this case, we have a trinomial because we have three terms in the mix here. All right. Now, what we worked on most last time was just adding or subtracting these polynomials, and for the most part we did binomials. So we would say this plus some other binomial, 3x to the fourth. But no, sorry. We'll say that it's 6x squared plus 7x. Okay. When we add or subtract polynomials, we just look for like terms. We can combine like terms. And these, the 3x squared and the 6x squared, are like terms because we have the same base raised to the same power, the same variable raised to the same power. So the base stays the same, and we just add the coefficients. This becomes 9x squared. It's this plus this. And then we can look for the next set of like terms. And remember, we always take the sign that's in front of the term if there is one. So a positive x plus a 7x, so I have 1x here, I have 7x's here, now I have 8x's. If this is, let's make all this go away here. If we have instead, if instead of addition, if we make this into subtraction. Okay, what do we do then? Well, then we're still looking for like terms, but then we subtract. It's this 3x squared minus this term. So 3x squared minus 6x squared, 3 minus 6, we get negative 3x squared. And then we have this 1x here minus 7x. So 1 minus 7, negative 6x. So that's addition. Well, what we're looking at today is multiplication. So when we multiply polynomials, today we're only really looking at polynomials multiplied by monomials. So this b out here, well, it's just the term, it is a monomial. So as long as it's just a monomial times a polynomial, we go back to our old friend the distributive property, where we're just taking what's outside the parentheses and multiplying it one step at a time with what's inside the parentheses. So this becomes b times b squared. B times b squared minus b times 12b. Right? And it's minus because that's minus. And then plus b times 1. Okay. So if we look at these just as individual steps, it's pretty easy to put this together. So what is b times b squared? Well, remember, if we have powers of like bases and we're multiplying them together, we just add the exponents. We have an exponent there of 1, so this is b to the first times b squared. So b to the 1 plus 2, this becomes b to the third minus, remember it's a 1b times 12b. Well, 1 times 12 is 12, and then b times b is b squared, plus b times 1 plus b. Sorry, I ran out of space there. Okay, so it's just a simple matter of the distributive property. Now, we can always kind of bypass this step if we do these really in order. If we just kind of look at this and say, well, what is negative 3 times negative 3m to the third times 2m to the third? Well, we multiply our numbers together. Negative 3 times 2, negative 6. M to the third times m to the third is m to the 3 plus 3, m to the 6th. Okay, and then we do the next thing. Negative 3m to the third times negative 12m squared. We always keep the sign that's ahead of this thing with that thing. So negative 3 times negative 12 is a positive 36. Negative times a negative is a positive. M to the third times m squared is m to the 3 plus 2, or m to the 5th. And we repeat this process. 3m to the third times a positive 2m. Negative 3 times positive 2, negative 6. M to the third times m, well, that's m times m times m times m, so m to the fourth. Okay. And then last but not least, right, the fact that this is a polynomial with 4 monomials in it, it's the same process as a binomial or a trinomial. You just do each step at a time. So negative 3m to the third times positive 25. Negative 3 times positive 25 is negative 75. And m to the third doesn't have any variable over here to change it, so it's just m to the third. So there's our solution. And that is our simplified expression. All right. So the next type of problem that we'll see is where we just have to do the same thing twice. Right? Because we have this multiplication of a polynomial by a monomial plus this multiplication of a polynomial by a monomial. All right, it's a few extra steps, but we can still do this. So we follow the same procedure. We just have to do this thing twice. Negative 3 times 5x squared. Well, negative 3 times negative 5 is negative 15, and then the x squared won't change because it's not being multiplied by another variable. Then we do this one. So negative 3 times negative 2, or positive 2, negative 6. And that x doesn't have anything to multiply it by. Negative 3 times positive 9, negative 27. Plus, because we have this plus, well, we have x times 2x. Well, the 2 isn't going to change because it's 1 times 2, and then x times x, x squared. X times a negative 3 minus 3x. Because it's a negative 3 times x. That's a negative 3 times x. Now we have to do that step where we can combine like terms here. So let's change colors here. So we've got a negative 15x squared and a positive 2x squared. We've got a negative 6x and a negative 3x. But then, of course, we've got this negative 27, which can't combine to anything. But okay, so negative 15x squared plus 2x squared, negative 13. Negative 15 plus 2, negative 13, x squared. Negative 6x, negative 3x, we combine those, well, we get a negative, let's get rid of that. So we have a negative 9x. And then, of course, our negative 27 doesn't have anything to go off of. All right. So we're going to skip over 9 so I can get to the other stuff here. Okay, but that's the kind of problem that you'll do in that section. So the last kind of problem that you have to do is here where we're solving these in an equation. And for these, we can look at this as two separate things. We have to simplify this, then we simplify this, and then we have an equation with one variable where that variable appears a couple different places in the equation. So as usual, let's take a look at how that's going to work. So we simplify this left side. We, again, as always, we're going to use our distributive property to get rid of these parentheses and simplify that. And of course, we can't forget about our plus t here. So 7 times t squared is 7t squared plus 5t. Well, it's 7 times a positive 5t. 7 times 5 is 35. And the t doesn't have anything to change it. And then 7 times negative 9 is negative 63 plus t, because this thing comes along for the ride. And I'm going to get myself a little bit more room to write here. Equals, and then t times 7t. So that's 7 times t, which is 7t squared. T times negative 2, negative 2t. Give myself a little more room. Plus, plus 13. Okay, so now we've got a big equation. All those parentheses are gone, but we just have to start moving variables to the left, combining like terms, getting rid of numbers from the right. So let's subtract 7t squared from this side, and we have to do the same thing to both sides. So those cancel, and lo and behold, those cancel as well. Let's say 35t plus t will combine like terms. 35, oops, not 35t, that's now 36t minus 63 equals negative 2t plus 13. So let's add 2t to both sides so that these will cancel. Now I have 38t minus 63 equals 13. Let's add 63 to both sides so that those cancel, right? We're moving our variable terms to the left. We're moving our number terms to the right. So we get 38t equals 78. Sorry, not 78. I'm an idiot. 76. We divide by 38 on both sides, and we get t equals 2. Okay. So it's kind of a bit of a ways to go, but we get t equals 2. Okay. So we're really just using a lot of examples of the distributive property, but we're using it further and further to simplify or solve equations that are a little more complicated. Okay, good luck.